actually no data is moved at that point. It's just moving pointers around to which chunk or which data lives on which chunk. So on the MongoDB processes, your data all stays in the same place. Nothing's going to happen. A chunk split is really only happening in the config servers. That's saying, okay, now all of these, this is a new chunk, and this data is in that chunk. Now that's important because of balancing. So there's another process in Mongo, and this actually is, I believe, part of the Mongo S process. It's a thread that's running in the Mongo S process that does balancing. And so it looks at all the chunks in your whole cluster and sees, there's 1,000 chunks on shard 1, but there's only 50 on shard 2. I need to move a lot of these chunks over, and it'll balance it. So over time, your shards are going to be equally balanced. So at that point is when data actually moves in chunks between MongoDB processes. So if it needs to move from shard 1 to shard 2, it'll move them over at that point. One really nice thing is this happens completely in the background. You can be writing to that chunk and you can be reading from that chunk all the while that chunk is being migrated. The algorithm they've got for doing that is great. So it'll, I think I'm going to go to that in a minute, so I won't talk about that algorithm. But from the application side of things, you really don't know anything's going on. It just happens magically. And if you look at your stats on your database, pretty much all of your data sizes are going to be growing pretty much equally. You probably notice it going like this on all of your databases. That's because it's just moving chunks over as it needs to balance them. And now I think in version 2.0 they improved the balancer, I believe, or maybe they were talking about doing it in 2.2. I don't remember. So before, in older versions, it only took into account data size, so that it would balance the size across the two shards. I believe now they actually take into account how busy or how hot a shard is. So if you're constantly writing to one shard, that's a lot more intense on the MongoDB process, So it may move some of the other stuff off of there, so that there's just this one chunk that's being written to all the time on this shard, whereas all the other stuff that's pretty idle might be over here. So I'm not exactly sure all the specifics of it, but I do know that they improved that. So what I said before may not be completely accurate. Your sizes may not be equal anymore, but the load on the database server should be, which is really the way that you want it anyway. That's really what you're concerned about. So this is just an example of migrating. So at time 3, we've got 4 chunks on one shard, all on shard 1. And as it goes through, it's going to migrate those one at a time. So at time interval 4, it's going to migrate this one over to shard 2. Time interval 5, it's going to migrate that one over. And at the end, you've got a pretty evenly distributed system. And finally, this is something of my own addition. We use EC2 for all of our stuff, which is Amazon's cloud services. And there's some important things that you need to take into consideration if you're using Mongo in EC2. We learned some of these the hard way. And EC2 actually is great for MongoDB, but you have to take this into account. The fact that Amazon makes no guarantees that an instance is going to stay alive at any point, so at any point any one of your servers could just die for no reason, you have to take that into account. So that's why it's important to have 3 replicas, because if one of your replicas goes down for whatever reason Amazon decides to shut one down, you have to be able to recover from that quickly. Also, for the same reason, you want to store your data on EBS, which is their external storage mechanism, so that it's not stored on the server. So if the server goes away, your data is still there, and you can just fire up another MongoDB process and connect to that data and still have it. And you also want to use journaling, so that if the database crashes in that sort of a case, there's no data corruption, which earlier versions didn't have journaling, and that was a problem. We had to rebuild databases quite a bit. And also, I would recommend, it's very important that you have good bootstrapping scripts, or use something like Chef or Capistrano to push out all of your, to build servers, and so you don't have to do them manually. Because if you have any sort of a larger setup in EC2, you're going to be doing this quite a bit, and it's nice to just run a script and say, give me a new shard and put it in this cluster, and it'll spin up everything for you. It's definitely worth the time investment to do something like that. And that was all of my very, very quick run through of how sharding works. I was talking that whole time. I was kind of hoping for more questions, but I don't think I left any room for questions. So on any of that stuff, was any of that unclear? Does anybody have questions we can talk about? Yeah?
So can you talk a little bit about compound keys in sharding?
Okay.
And I guess I'm thinking about why you would choose to use the MD5 hash for pieces of data as opposed to using the compound key of that same data.
Okay. Yeah. Okay, so let me go back to that example. This example here. So one option would be to do a compound key on app and timestamp. The problem with that is, depending on the cardinality of app, if in the example that I gave we had 2 applications that were logging, so the cardinality is just 2, we're still going to have the same problem. We're going to have 2 hotspots that we're writing to at that point. One for Nginx and the right now timestamp for that, and one for our other application and the right now timestamp for that. If your cardinality on this is large enough, it might not matter. Like if you have 20 applications, you could probably get away with doing that. It really depends on your data set.
So the internal representation of the compound key reserves the, I guess it's the product of the cardinalities of the keys involved?
Yes, I believe so. It's based on uniqueness. So the first thing it would look for was app. And if app is unique, it's going to stick it to where app is. If there's 2 where app is the same, it's going to look for timestamp to make it unique between them, and figure out which, or I guess that would be for the chunk creation. If you have enough of this to make it unique, it really would never need to use timestamp to create a unique value. But it can't split up. If you have, I think I'm doing a poor job of explaining this. If you have, if you only have 2 values here, Nginx and Apache, let's say, those are the only 2 possible chunks that you would have. You can't split it up any further than that. Is that answering your question?
Yeah, I was trying to understand whether, like I said, whether that would affect basically the number of potential shards. Because maybe internally it would store a hash of those 2 things or something like that.
No.
So it was equivalent, but it sounds like it's doing something simpler than that.
Yeah, it is simpler than that. I see where you're going. No, it only creates a new chunk when it needs it. So the uniqueness of the value you're giving it is giving it more possibility of where to create chunks. Yeah. So when you first create it, there's only going to be 1 chunk. It doesn't have to pre-compute all the possible combinations of all of these. It's going to figure out the halfway point between the 2 when it needs to create a new chunk, and then all you have is 2 chunks. It doesn't have to create the cross product of all these values and create them up front. Yeah.
I think this might help me understand the situation and kind of the same thing he was asking about a little bit better. You referred to doing a hash of the app and the timestamp. For purposes of why you're using what you're using here, what advantage do you get by including the app as opposed to just hashing the timestamp?
Well, if you just hash the timestamp, well, actually, that's a good point. That's actually a very bad example. if you just include the timestamp, the MD5 is going to be the same
For a second.
for a
Or
second.
yeah, you can have multiple log statements coming in during that 1 second.
During that 1 second, all your writes are going to go to the same place. The next second, your writes might go somewhere else. So your hotspot's going to be shifting in that case. And so including this in there is pretty much the exact same problem. So that was a very bad example, wasn't it?
If you have a lot of apps,
What's that?
if you have enough apps, then
Yeah.
it's probably distributed.
In practicality, it might not be a problem.
So-
But you don't want to just do a random MD5 because you need to be able to compute it when you at query time, so you can query based on it. So it pretty much needs to be something with the data that you already have. Yeah, in practice, I think it would work because your hotspot, because of the combination of those two, your hotspot is shifting every second, and if you have a decent cardinality on an app, that might spread it out enough.
Look, I'm gonna try to fix the lights while
Okay.
you're live.
Thanks. Yeah.
I would ask you a question about EC2 in particular.
Okay.
If you have 3 replicas in different availability zones, do you really need EBS? Because I've heard there are some problems with EBS from a performance perspective and reliability.
Yeah.
Why could you not use local disks for that?
2 reasons that come to mind. Local disks would be faster in most cases. You're limited on size of those, for one. EBS you can grow as big as you want for a single instance. The other